Problem 3a. Plot the point, -2, -5 pi over 4, and then change that point into rectangular coordinates. We start off in the middle, go 2 to the left, and then rotate around. That's a half a pi. That's a whole pi. And then we'll go a quarter more. It's 1 1/4 pi, and your spot would be right there. Changing it to polar coordinates, if you know your unit circle, is pretty easy. So you have x is equal to r cosines of theta. R in this particular point is -2. Cosine of theta, which is -5 pi over 4. You look at the unit circle and reduce that. You'll get square root of 2. Y is equal to r sine of theta. So y is equal to -2, which is the radius, sine of -5 pi over 4, and you get rad 2. Now, one thing you should always do is take a look and see, does this point make sense? And I would argue that it doesn't make sense because the point square root of 2, square root of 2 is in the first quadrant, and we're not in the first quadrant, we're in the fourth quadrant, which means I made a sign mistake. Y is equal to -2 sine of -5 pi over 4 is actually negative rad 2. So we get an answer of rad 2, comma, negative rad 2, and that fits the fourth quadrant. Problem 3b, 4 comma, negative pi over 3. Go out to the right, 4 spaces, and rotate. Negative pi over 3 is about 60 degrees, going clockwise because it's negative, and we end up right about there. Again, changing it to rectangular coordinates, x is equal to r cosines of theta. So x is equal to 4 cosines of negative pi over 3. You get 2. Y is equal to r sines of theta. Y is equal to 4 sines of negative pi over 3. And you get -2 rad 3. So it's the point 2 comma, -2 rad 3. And that fits because it's in the fourth quadrant.